Right, so we have this question here. A, B, and C are 2 by 2 matrices such that A is A, B, C, D. B is 5, 3, 3, 2. C is 14, 0, negative 9, 5. They want us to find the value of 3A. Right? So let's start with that. So part A is equal to A, B, C, D. So 3A will be 3 by A, B, C, D. That will give us 3A, 3B, 3C, 3D. That's it. That's all you have to do. Right? Part B. They tell us B is equal to 5, 3, 3, 2. Now we want to find B inverse, right? I always like to put this equal to A, B, C, D as well, because when we're going to put our formula is going to use the letters A, B, C, and D in it. Right? So B inverse could be found by 1 over AD minus BC. This is the determinant by the adjoint D minus B minus C A. So B inverse, given that 5 is A, 3 is B, 3 is C, 2 is D, will be 1 over 5 by 2 minus 3 by 3. And then our adjoint is going to be 2, 5, negative 3, negative 3. Looking down. So 5 by 2 going to give me 10. 3 by 3 going to give me 9. Well, nice, easy question to work out. We're going to get 1 over 1. Multiply by this. And we know 1 is the multiplicative in identity. So everything here by 1, we're going to give me back the exact same thing. And that's B inverse there. Right? Part C says find 3A plus B inverse. So we're combining parts A and B together. So part 3, they want 3A plus B inverse. We worked out 3A already to be 3A, 3B, 3C, 3D plus B inverse, which is 2 minus 3 minus 3, 5. Remember, we add in similar positions. So 3A plus 2 going to go here. 3B plus negative 3 would be in this location here. Plus negative 3 will give me overall negative, right? And then 3C plus negative 3 will give me 3C minus 3. And then 3D plus 5. So this is the matrix 3A plus B inverse. Now they're going towards equal matrices. They want us to find the values of A, B, and C if 3A plus B inverse is equal to C. So what we just worked out for part 3, which is 3A plus B inverse is equal to C. We will need to put that matrix 3A plus 1, 3C minus 3, 3B minus 3, and 3D plus 5 is equal to the matrix C. And the matrix C is 14, 0, negative 9, and 5. 14, 0, negative 9, and 5. So if they are equal, it means that their corresponding positions are the same. So 3A plus 1 is equal to 14. So we could work this out. 3A is going to be 14 minus 1, 3 is equal to 13. A is equal to 13 over 3. Then 3b minus 3 is equal to 0. Right? So 3b is equal to, pay attention to this. When I carry this across, that 0 is staying there. This becomes plus 3. It's not going to become 0. We're not multiplying. So the answer here is 3b is equal to 3. B is equal to 3 divided by 3. B is equal to 1. Right? So we did this position. We did this position. Right? Matching it against these. We're going to do this one now. Matching against this. 3c minus 3 is equal to negative 9. 3c is going to be negative 9. Notice how I'm writing it back. Equal sign under equal sign. This is the number that I'm moving across. I'm going to get negative 6. And that divided by 3 giving me negative 2. Right? And then finally, we're going to look at this one, where we have 3d plus 5 is equal to 5. This should become negative 5. 3d is equal to 0. D in this instance will be 0 divided by 3. D will be 0. And that's how you're finding your values for A, B, C, and D, right? Using your equal matrices. Right, give me a thumbs up if you're okay with that.